Good morning, class, or good afternoon. Today's lesson is going to be on how to find the equation of a straight line given a number of different scenarios. So our heading is finding the equation of a straight line. Now, to find the equation of a straight line, we need two pieces of information. Now, that means we can either have, for example, if we have the gradient and the y-intercept, well, that's probably the easiest problem you'll ever get. So if there's two pieces of information, if you know those two, you can determine the equation of a straight line. Remember, the gradient is m and the y-intercept is c. So for example, if m was 3, if m equaled 3, and if c equaled -4, then our equation would be y equals 3x minus 4. Now, it doesn't get any easier than that, but the examples we're going to be doing are a little bit more difficult than that. So that's one example of having two pieces of information to work out the equation of the straight line. But other combinations, other information you might get is this. We might have one coordinate, we might have one point on the line as well as the gradient. There's two pieces of information as well. We might have two different points on the line. Once again, we have two pieces of information. So as long as you have two pieces of information, then you have enough information to actually determine the equation of the straight line. For example, another version of this might be, you might have one point and you might have the y-intercept. Which actually, when you think about it, the y-intercept is just another point, isn't it? So this is just a special case of this. Okay, so we now know, to summarize all of this, we now know we need two pieces of information in order to generate the equation of a straight line. So let's explore some of these more challenging examples. So I'll now clear this. Example 1. So let's say we've got the gradient and one point on the line. So let's say we've got a point on the line and the point is, we have the point 3, 8. We know that sits on the line, and we also know that the gradient equals 3. So if we were to draw a sketch of this, just to help us visualize what's going on, I'll draw a little graph over here. Okay, so there's our y-axis, and there's our x-axis. Now the 0.38, well, I'm just going to estimate that. 1, 2, 3. It's going to be up there somewhere, let's say. There's the 0.38. And it's got a gradient of 3. Well, it's a positive gradient. It's going to be an uphill gradient. It's going to be doing something like that. So we don't have to be accurate here. We just kind of get an idea of what the line's actually doing. So there you go. Just something that could be a possible example. Okay. So we know one point. We know the point there, and we know the gradient. How do we work out the equation of the line? Well, it's actually quite easy. We always start with the general form. So we know the general form of any linear equation is y equals mx plus c. Now in this case, we know that the gradient is 3. So I can now say, well, at least I now know that y equals 3x plus c. So that instantly gives me the value of m, because remember, m is the gradient in our general form. So we've got some of the way, but we haven't got our y-intercept. But what we do have is the other piece of information. We have this piece of information here. And this is actually very, very important, because this is telling us when x equals 3, remember that's the x value, when x equals 3, y equals 8. So when x equals 3, y is equaling 8. So if I was to substitute the value x equals 3 into my equation, I know that the answer has to be 8. So what I can now do is substitute the coordinate, or the coordinates, and it's 3, 8 into the equation. Into this equation here. So let's go ahead and do it. So remember, 3 is our x value, 8 is our y value. So I'm going to write this again, but this time where I see y, I'm going to replace it with the number 8, and where I see x, I'm going to substitute the 3 in, x equals 3. So I've got 8 equals 3. Now it's 3 times x, so it's going to be 3 times 3 plus c. All right, so therefore 8 equals 9 plus c. Well, guess what? We can now rearrange this equation to work out what c must equal. So subtracting 9 from both sides, we can see that c must equal 8 minus 9, which is equal to -1. So finally, our equation, which is what we were trying to find in the first place, is going to be y equals 3x. We knew they had the gradient of 3, so y equals 3x. And we now know that the y-intercept is -1, so it's -1. So clearly, my graph was a little bit wrong, because I should have thought this through. It was actually more like that's actually what the graph is really doing. So this one here, that was incorrect, but that's okay. This happens. You might draw a graph, and when you actually do your calculations, it turns out not to be the case. You realise it's something else, and that's fine. That's what science and math is all about. Investigation. So there is our equation for this particular set of information. Right. Example 2. Let's say in this example, all we've got is 2 points on the line. And those points are -5, -7, and let me see, 7, -11. Okay, so they're the 2 points. We have to find the equation of the line that passes through those 2 points. That's the question. Find the equation of the line that passes through these 2 points. So once again, I'll draw a little sketch just so we can see what we're doing. So I'll draw my little axes over here. So we've got the y-axis, and we have our x-axis, like that. Now, -5, -7. Well, -5, that's going to be way down here somewhere. Okay? -5, -7. The other point is 7, -11. So it's going to be 7, -11. Well, that's down here like this. So it'll be about there. So 7, -11. So our line, and this just remember, it's just an approximation. It's just a way of seeing what's going on. So there's something to visualize. That's all. So I think my line's going to do something like that. Okay. So let's see if we can find the equation. Well, what we can do, because we now have 2 points, we can find the gradient first. How? Well, we know that the gradient, to work out the gradient, m, it's y2 minus y1 over x2 minus x1. So we just have to nominate one of these points as point number 1 and point number 2. And just to make a point, no pun intended, I'm going to call this point number 1, and I'm going to call this point number 2, just to show you that it doesn't matter which one we call which. So if that's the case, then this is going to equal y2. Well, y2, there's my number 2 point, and y is the second value, so y2 is -7. So it's going to be -7 minus y1, well, y1's over here, and it's -11. So it's minus -11. Now watch those negative signs, okay? We've got minus -11. On the bottom, x2 is -5. And minus, because the formula says minus. Now x1 is 7. So let's simplify that. So that's going to be, just going down here, it's going to be -7 plus 11. Remember, double negative means double positive, or just a positive, so it's plus 11 over -5 minus 7 is minus 12. So over here, sort of going in reverse order, I'm sorry about that. So 11 take away 7, 11 take 7 is in fact 4. So it's 4 on the top, and on the bottom it's -12. So it's -4 over 12. There's our gradient. So m equals -4 over 12. And guess what? It's a negative gradient, a downhill slope. And what do you know? We sort of predicted that would be the case. But we can simplify this. 4 goes into itself once and into 12 3 times, so it actually can be simplified as -1/3. So there's the gradient. So now we know that the equation so far is y equals -1/3 x, but we don't know what the y-intercept is, so we just write plus c. So that's where we are at the moment. We've now got to work out c. How might we do that? Well, we could do it exactly the same way that we did it in our last problem. Pick one of these points. Now, we've got 2 points to choose from. All we have to do is pick one of them, substitute that value or that coordinate into our equation for the x and the y value, and work out what c is. So that's what we're going to do. So I will erase up here. Okay. So I'll pick this point here. I'll pick point 2 that I'm going to substitute in. So we're going to substitute. That's right, sub in -5, -7. We're going to substitute -5, -7 into the equation y equals -1/3 x plus c. So remember, there's our x value and there's our y value. So it's going to be -7, there goes our y, equals -1/3, -1/3 times, now x is -5, plus c. So if we simplify that, that's going to be -7 equals, now we're multiplying a fraction by a whole number. When you're doing that, the whole number multiplies by the top part of the fraction. So it's -5 times -1. In fact, it's going to be 5. So equals 5/3 plus c. Okay, so we're nearly there. Now to find out c, I'm just going to take this fraction here, and I'm going to subtract it from both sides to move it to the other side of the equation. So moving to this line, I've now got c equals -7, and I had to subtract the 5/3, so I've gone minus 5/3. Now, we can do this as a mixed. There are a number of ways we can do this. I might do this as a mixed number. So we're going to go -7 minus, now 5/5 is actually 1 2/3. So minus 1 2/3. So -7, take away 1, was going to give us -8. We're also taking away 2/3 as well, so that's going to be -8 2/3. And convert that back into an improper fraction by multiplying the 8 with the 3. 3/8 are 24. Then adding the top number, it's 26/3. So minus 26/3. So finally, there's our y-intercept. So we now know what the equation is going to be. The equation will be, here we go, here is the final answer. Y equals, now remember the gradient was -1/3, so it's -1/3 x plus c. Well, c is -26/3 minus 26/3. And if you're able to simplify that, you should have, but in this case we can't. I should also point out that we're now getting into the realm of mathematics where you need to give exact answers, so do not convert that to a decimal unless you're asked to do so. So, ladies and gentlemen, there is the final equation for this problem. So hopefully that's given you enough information to go ahead with exercise, I think it's 3D. Okay, thank you very much.